Welcome back to JavaScript the Basics. In this lesson, we're continuing our look at functional programming. Specifically, we're looking at the reduce method on arrays. In our past lessons, we looked at filter, which rejects elements based on a true or false value when creating a new array, and map, which doesn't reject any elements but transforms all of them into a new array. Let's go back to the Twitter image we saw when we first looked at this section on functional programming, which gives us pseudocode for what the higher order functions map, filter, and reduce do. For map, we see there is a callback function working on every element in the array. In this case, the function is cook, which cooks each element, aka transforms them into a new array of popcorn, a hamburger, and some eggs. Filter then uses a callback function on each element of the array called is vegetarian, and based on a true or false value, returns all true values to a new array. Now, on to reduce. In this emoji pseudocode, we see that a callback function acts on every element in our array, but it does so in such a way that our element of popcorn and eggs are reduced to one element, in this case, the end of the digestive tract. Reduce is great for list transformation. If you can't find a pre-built list transformation method, then reduce is for you. The reduce method applies a function against an accumulator and each value from the array, from left to right, to reduce it to a single value. The reduce method executes a provided function for each value of the array. The return value of the function is stored in an accumulator. Let's start off by looking at the syntax of the array method reduce. Here we have array with the reduce method attached to it. We've passed to that a function with the parameters of accumulator, current value, index, array, and initial value. The first argument is the accumulated result of the reduction so far. If there is an initial value, this will be in the accumulator where we start, also known as the previous value. This is the cumulative value returned through each callback. This is required. Next, we have the current value. This is also required. This is the current value of the element. Next, we have the array index of the current element, followed by the array object the current element belongs to. Alright, let's go ahead and look at an example to see how this works. Let's declare a variable called numbers. We'll assign it a value of the array with the elements 1, 2, 3, and 4. We'll use the reduce method on this numbers array. We will pass to it the callback function with parameters for accumulator and current, which are required, and index and the array object that are optional. We will also tack on the optional initial value. Now, let's see what the reduce method looks like in action under the hood. Let's create a column for our accumulator, current value, index, and array object, as well as the result to track where we are at. Because we gave our reduce method an optional initial value, that will sit in the accumulator when we get started. Our current value is the number 1 at index 0 of the object array. The result of our code block of accumulator plus current value is 6. Remember, this is like a loop, so we are going to continue to move through our array. We have an accumulated value of 6. Our current value is 2 at index 1 of our array object. When we add the accumulator to the current value, we return a result of 8. When we go back to our accumulator, now with the value of 8, we'll add it to the current value of 3 at the index 2 in our array object with a result of 11. Finally, we'll go through one more time. Our accumulator has the value of 11 added to the current value of 4 at index 3 for a total of 15. There you go, a basic implementation of the reduce method on arrays. Now, Let's go ahead and do this one more time with a little more complex approach. Let's reduce multiple arrays within one array into one array. We'll start off by declaring a variable called multar, which will assign the value of array with 3 elements within it, each element an array with 2 elements within it. We'll attach our reduce method to our multar variable. We'll pass to it the callback function with the parameters of accumulator, current value, index, and array. The only value we are returning will be in regards to the accumulator and the current value. We'll go ahead and demonstrate what is going on under the hood with some rows and columns showing how reduce works. First, in our accumulator row, we already have an initial value given to us. It's an array with the values of -2 and -1. We can see in our code block that we are going to return the value of our accumulator, in this case -2 and -1, and concatenate it. We learned about concatenation in the JavaScript building blocks section of the course. Feel free to go back to that or Google the concat method if you need a refresher. Essentially, in this case, we are taking the elements of the array passed as an argument to the concat method and attach them to the end of the array the method is attached to. So when we concat the array of 0 and 1, and index 0, which is -2 and -1, we get a return value of an array of -2, -1, 0, and 1. When we repeat the process with an accumulator value of an array of -2, -1, 0, and 1 at index 1, with an array of values 2 and 3, and we concat this onto the end of the array for our new return value, we have an array of -2, -1, 0, 1, 2, and 3. We repeat this process one more time, returning a final value of a single array with the elements of -2, -1, 0, 1, 2, 3, 4, and 5. And that's it. Thanks for taking this first look at the higher order method of reduce for arrays. We'll see you in the lab to put what we have learned into practice.